If you look along the coast of California, there are these incredible underwater kingdoms. They're these vast, swaying forests of kelp, just teeming with life. Biodiversity hotspots that are as important to the coast as rainforests are to the land. But just a few years ago, these majestic forests, they started to vanish.
So what happened? We're going to dive into that, because the story of their collapse is this amazing ecological detective story. It's full of surprising culprits, unexpected heroes, and some really critical clues about the future of our oceans.
All right, so our investigation really kicks off around 2014. Scientists, divers, people up and down the coast, they started to see that something was deeply wrong. These once dense, vibrant kelp forests were disappearing at this just alarming rate. And this wasn't just a bad season, no, this was a massive, catastrophic collapse. And to give you a sense of the scale here, just look at the Santa Cruz region. The kelp cover there dropped by a factor of 12. Can you imagine a forest on land losing over 90% of its trees in just a couple of years? That is the level of devastation we are talking about. So, what on earth happened?
Well, for decades, we all thought we had the kelp forest story completely figured out. It was this simple, elegant tale of a hero and a villain, and for the longest time, it really seemed to be the only story we needed.
So here's the classic story. It's what's called a trophic cascade. At the top, you've got your heroes, the sea otters. They are a keystone species, and they absolutely love to eat sea urchins. And that's super important because sea urchins, well, they're like little lawnmowers that can graze down an entire kelp forest. So you keep the otters around, they keep the urchins in check, and the kelp thrives. Simple, right? But here's the twist. The collapse happened even in places with plenty of healthy sea otters. The usual suspect had an alibi.
And this is where our detective story gets a whole lot more complicated. The evidence starts pointing not to a single bad guy, but to, well, kind of like a conspiracy of factors, a perfect storm of environmental disasters that all hit at the exact same time.
You see, it turns out there was another major player in this ecosystem that we kind of forgot about. We always focused on the sea otters, but they were not the only predator hunting urchins. For years, this massive, multi-armed sunflower sea star was also on the job. The whole ecosystem was just way more stable and resilient with two different predators keeping those urchins in check.
But then, disaster struck. Starting in 2013, this mysterious illness called sea star wasting disease just ripped along the coast. It was an absolute apocalypse for sea stars, and the sunflower sea star was hit the hardest. Its population crashed by a staggering 97.5%. And just like that, one of the kelp forest's most important guardians was gone. And you can see how this all played out in this devastating sequence. With the sea stars gone, the whole ecosystem was vulnerable. And then, in the summer of 2014, the second punch landed. A massive marine heat wave, they nicknamed it the blob, showed up, warming the coastal waters like never before. The kelp was already stressed, its ecosystem was weakened, it just didn't stand a chance.
But here is an absolutely incredible clue that scientists found. They had a model that looked at the ocean conditions from the winter of that year. Things like temperature and nutrient levels. And get this, that model was able to predict the massive summer collapse of 2014 before it even happened. That tells you that the environmental conditions were so bad, so nutrient-starved, that the kelp's fate was basically sealed months in advance.
Okay, so the heat wave, the blob, it eventually went away, which led to the really big question, the cold case that was puzzling everybody. Why didn't the kelp forests grow back? The thing that triggered the collapse was gone, but the crime scene, it stayed a crime scene. And the answer has to do with this new ecological state, something called an urchin barren. See, with their main predators gone and the kelp already weakened, the purple sea urchin population just exploded. They swarmed the seafloor, eating any tiny piece of new kelp that tried to grow, and they created and maintained this desolate, barren, underwater landscape. So here's the crucial point. Remember that same model that so accurately predicted the collapse back in 2014? Well, after 2015, it completely failed. By 2017, the environmental conditions were good again, and the model was predicting a strong recovery for the kelp. But in the real world, nothing. Nothing grew back. The fundamental rules of the ecosystem had changed.
The research spelled it out pretty clearly. The problem wasn't the environment anymore. It wasn't just warm water. It was now biological, or biotic factors. In other words, the extreme sea urchin herbivory, which is just a scientific way of saying the massive overgrazing by all those urchins, had completely taken over. It locked the system in this barren state that even a healthy sea otter population couldn't fix on its own.
But you know, amidst all this devastation, there is a glimmer of hope. Scientists noticed that some kelp forests, especially down in Southern California, were surprisingly resilient. They actually weathered the heat wave much better than the others. And the question was, why? Well, the answer was found in this kind of hidden secret process happening in the ocean.
And that answer is something called internal waves. Now, just think of them as waves that happen deep underwater. They travel right along the boundary where the cold, nutrient-rich deep water meets the warmer surface water. And as these waves move towards the shore, they can act like a pump, pushing all that vital, cold, nutrient-filled water up into the kelp forests.
Now, in a normal year, these internal waves are a pretty minor part of the kelp's diet. The vast majority of nutrients, we're talking about 90%, comes from this big, large-scale seasonal upwelling of cold water. So the internal waves are just kind of a little snack on the side, maybe 10%.
But, and this is the amazing part, during a marine heat wave, that big seasonal upwelling machine completely shuts down. The surface water gets warm, and it just stays warm. And in those moments, those little internal waves, they become an absolutely critical lifeline. They can end up being responsible for delivering up to 100% of the available nutrients, basically keeping some kelp forests alive while others are completely starving.
This whole ecological mystery, it's taught us so much. It's revealed these hidden complexities, and it's forced scientists to develop some really innovative new ways to keep an eye on the health of these crucial ecosystems, so we can be ready before the next crisis hits.
And one of the most amazing new tools is sound. Yeah, that's right. Scientists are literally using underwater microphones to listen to the kelp forests. A healthy, vibrant forest is a noisy place. It's full of the snaps and crackles and calls of all the fish and invertebrates living there. An urchin barren, on the other hand, is just eerily silent. By monitoring this soundscape, we can get a real-time diagnosis of how the ecosystem is doing.
You know, the story of California's kelp forests really is a stark warning. We now have models that can see a disaster coming months away, and we have new tools to listen for the earliest signs of trouble. So I think the ultimate question is, can we use this knowledge to actually support these vital underwater worlds? And can we learn to act on the warnings before they fall silent for good?